we're going to continue lesson 15 part 2. In this case, remember, we're having the key of this homework. As always, we start with an example. For example, we have this table. It says you can compare the slopes and y-intercept of a system of equations to predict how many solutions the system has. So we'll start with these two systems. I'm going to start with these two. For example, look at this one. So I have slopes. They are different. It's 2 and 1 every time. If you don't have a number in front of your x, put 1. So instead have 2 and 1. They are different. And this y-intercepts, okay, the constant number, are different. How many solutions? One solution. So this table is really important. Different slopes, different y-intercepts, you get one solution. Now here, you have different slopes, 4 and 2, same y-intercept, you get one solution. And this one, if the y-intercepts are the same, we usually get x or y equals to 0. Okay, that's what we usually get when we have the different slopes and same y-intercept. Now, if we move to the third system, we have the same slope and different y-intercept. Same slopes, 3, different y-intercepts, -2 and 3. What we have? No solution. We're going to solve some problems, those ones later. Then we have the last one, same slopes, same y-intercept, in this case 2 and 2, -3 and -3, and we have infinitely many solutions. So let's go over problems 1 through 6. Problem number 1, it says, look at the slopes and the numbers of solutions for the first two systems. This is 1, this is 2, this is 3, and this is 4. For the first two systems. And then it says, in example, what the system have in common, what they have in common. So in this case, the equations in each system have different slopes and going to have here each system each system has one solution. Okay, so that's what we have in common. We have different slopes, so we get also one solution. Those two got one solution. Now here, use the coordinate grid, this one, showing a graph of the third system of equation. Okay, why does the system have no solution? Why that system have no solution? So we need to graph. So I have here, I'm going to say y equals 3x minus 2 and y equals 3x plus 3. Remember, to do rise over run, we put a 1 in the denominator if we don't have a fraction. And to graph in this case, we're going to start with the y-intercept, -2. So I'm going all the way to -2. Okay, I'm going up 3 units, 1, 2, 3, and 1 to the right, and then I'm going to graph. So let me use the ruler here. I'm going to graph this system. Okay, that equation is done. Now I'm going to do the second one. I'm going to use different color. So I have +3, so I'm going to 3. Again, I'm going up 3 units to the right, 1, 1, 2, 3, right 1. So in this case, I graph the second one. And then we answer the question. What is the question? Why does the system has no solution? So before I start writing, I can see that these two are parallel lines. Those are parallel lines. That means they are never going to intersect each other. That means there is no solution. So in this case, I'm going to write here, the slopes are the same. Okay. And the y-intercept are different. So the lines are parallel. Okay, the lines do not intersect, so there is no solution. Okay, so the lines are never going to intersect each other, so there is no solution in this case. So that's page 171. Page 172, we are going to continue use the system of equations to solve problems 3 to 5. And in this case, I have equation 1, 2, and 3. So problem number 3 says, form a system of equations with equations 1 and 2 without graphing. Explain how you can tell how many solutions the system has. Okay, so I'm going to do the following. So I have y equals 2x plus 3, and then I have y equals 2x minus 3. In this case, we have same slope, different y-intercept, as you can see. So in this case, we're going to have no solution. So if we compare these two, it's going to be no solution. Here I'm going to write here the equations have the same slopes and different y-intercepts. That means the lines are parallel. If the lines are parallel, the lines do not intersect. So there is no solutions. Okay, so number 4, I have form a system of equations with equations 1 and 3 without graphing. Explain how you can tell how many solutions the system has. Okay, so equation number 1, remember, is y equals 2x plus 3, and equation number 3 is 2y equals to 4x plus 6. Now, equation number 3 got 2y. I need to get rid of that 2 first before I start doing observation. So divide by 2, divide by 2, divide by 2. So this one's is going to be y equals 4 divided by 2 is 2x, 6 divided by 2 is 3, and the first equation is y equals 2x plus 3. Same slope, same y-intercept, infinitely many solutions. So in this case, we're going to write for number 4. Let me move this one here. After we divide both sides by 2, we compare. We can see that slopes and y-intercepts are the same. So the equations have the same slope and same y-intercept. That means the lines are the same. So there are infinitely many solutions. Okay, number 5. I have Tonya says that a system of equations formed by equation 2 and 3 have the same number of solutions as system formed by equations 1 and 2. Is she correct? Use your answers to problem 3 and 4 and help explain this reasoning. So what we are going to do for problem number 5 is, after we do the observation, she is saying, Tony says a system of equations for equation 2 and 3 is the same as equations 1 and 2. I'm going to notice that, remember that the first one, 1 and 2, there's no solution, okay, because the slopes are the same, y-intercepts are different, and in this case, if I put together equation 2, y equals 2x minus 3, and equation number 3, which turned out to be y equals 2x plus 3, is also no solution. So in this case, Tonya is correct. Okay, Tonya is correct. After observe those two equations put together, using problem number 3 and 4, Tonya is correct. Okay. And number 6, I have the system of equations shown below has no solution. Change one number in one of the equations so that the system has no solution. So that the system has one solution. Graph your new system on the coordinate grid to support your answer. So I'm going to target the first equation, so the first function. So in this case, the first one, I'm going to say y equals, and I'm going to change that to for 4. So 4x minus 1. See, I just changed one number. So I'm going to graph it now. So I'm going to graph it here. And I'm going to start with the -1. Okay, -1. I'm going up 4 units because I changed the slope from 2 to 4. So 1, 2, 3, 4, right 1. Now I'm going to graph. So in this case, my line. Okay. And now I'm going to graph the second one, 2x plus 1. I'm going to start with 1. That's the y-intercept. And then I'm going up 2 units. 1, 2 to the right 1. See where they're going to intersect. Okay. So if I graph these two. So those two lines are going to intersect each other. Where? At this point. Where's this point? 1 and 3. 1 and 3. That's going to be your solution. You get one solution. So now in this case, what I did was change 2 in the first equation. Okay. To 4. The new equations are y equals 4x minus 1 and y equals 2x plus 1. Okay, the slopes are different, so there will be one solution. And as you can see, the graph is showing that that solution is 1, 3. Last part of the homework, lesson 15, is page 173 and 74. But page 173 is a reading of an example. It's a reason and write. So we have 3 systems. You choose one of the system without graphing, explain how you can use the slope. So I invite you to read that example. It's already solved. You end it with parallel lines. That means no solutions. So it is important to read. Where does the example answer all the part of the problems? Use words to explain. Use the graph to explain. Use numbers to explain. So we've been doing that one through the lesson. So now we're going to solve one. So I have solved the problem. Use what you learn from the model. Okay, so in this case, consider the equation 3y minus 6x equals to 9. And then it says, write another equation that forms a system of equations with the equation above that has either one solution or infinitely many solutions. So in this case, I'm going to start converting this equation into slope-intercept form. Remember, y equals mx plus b, so we can compare. So in this case, we're going to add 6x plus 6x. So this one turns into 3y equals to 6x plus 9. Then we're going to divide by 3, 3, 3, every single one. So these two goes away. So I have y equals 6 divided by 3 is 2x plus 9 divided by 3 is 3. So I have y equals 2x plus 3. Now here it says write another equation that forms a system of equations with the equation above that has either one solution. So I'm going to do one solution. So my equation is y equals x plus 3. So I'm going to have the same y-intercept, but the slopes are the same. The slopes are different. In this case, remember, if I don't have a number here, I'm going to put 1. So let me graph those two equations. So for example, the first equation, I start at 3. I go 2 units up and 1 to the right. 1, 2, 1 to the right. then I graph. In this case, graphing the second one, I have plus 3, so I'm going to start at 3 again. I go up 1, right 1, and then I graph these two. Okay. And as you can see, I have one solution. It's here. 0 in x, so I'm going to write 0 in x and 3 in y. That's my solution for that system of equations. Now in this case, what I did, okay, you need to show your work, use words, models, and numbers to explain your answer. So in this case, first, I solved the given equation for y to get y equals 2x plus 3. That was the first step that I did. Then for the system that has one solution, the slopes must be different. So y equals x plus 3 will form a system with one solution. And in this case, my graph confirms, okay, I'm going to say my graph of the system supports my equation. The lines intersect at one point. In this case, the point is 0, 3. So there is one solution. Okay. If you do infinitely many solutions, here infinitely many solutions, then remember the first equation is 2x plus 3. So I have y equals 2x plus 3. And to have infinitely many solutions, we need the same slopes and the same y-intercept. So in this case, I will have the other one will be y equals 2x plus 3. You can write your reason here if you want. You can graph it. For example, you can say for the system to have infinitely many solutions, the equations in the system must simplify to be the same equation. So you have to be ended with 2x plus 3 and 2x plus 3. And then if you graph it, you need to prove that those two are the same. It's going to be a same line. So in this case, this is the solution for lesson 15, part 2. And I hope you have a wonderful day.